Hello guys, welcome back. In today's lecture, we will see the remaining part of the application based combined loading and stresses. Okay, last lecture we have seen up to the rectangular section. There you have given the core, or we can say the kernel of section. Okay, we want to find out that section. Then how to find out that section we have seen with the help of eccentricity, and you will get the relation is there. First, see the second section is a circular section. Okay, then how to find out the eccentricity we value on the circular section. Okay, this value is the E value on the centroidal axis to the top of the section of this. This section is called as a overall common section. Okay. Then see, you will get this value is a T by 4. T by 4. You know that how to find out that this value. You know what is the eccentricity? E is equal to Z by A. What is the value of sectional modulus of this? You have to calculate. Again, Z is equal to I by Y divided by A is there. What is the value of I? Y by 64 into D raised to 4. What is the value of Y? Y is the D by 2 is there. And what is the area? Pi by 4 into D raised to 4 is there. Then you will get this value E 2E is equal to D by 4. Okay, similar way, if you are given the hollow rectangular section, then there you will get the two value. One is the depth for the another rectangular, and outside rectangular you will get the capital D value. Check that, capital D value. Okay, and small d value you will get the internal rectangular. And similar way, width and small width and big width you will get for the two rectangular respectively. Then you will get the Ex. How to calculate that Ex value? Similar way, again, what is the Z value, or we can say again Z means what? Sectional modulus is nothing but it is the ratio of moment of inertia to the Y bar. What is the Y bar? Topmost distance from the centroidal axis or bottom. Okay, you have to find out this distance. With the help of that, you can calculate the I. We have seen already how to calculate the I value, how to calculate the Y bar value in the unit number 3. Similar way, you have to find out the Ex is less than, you will get the Bd cube minus Bd cube, small Bd cube divided by 6D into bracket Bd minus capital Bd minus small bd. And how to find out the eccentricity about the y axis? Here is the two axes, x and y axis. How to calculate this? Ey is less than db cube. This b is replaced by d. db cube minus small db cube divided by 6b into bd minus small bd. And last is the hollow circular section. If you have given the hollow circular section, then what is the value of I? You know that I is equal to pi by 64 cube minus small by 64 db cube. Okay. And what is the y bar value? Again, this d divided by 2, capital D divided by 2. And you will get the eccentricity. This E is less than or equal to d square, capital D square plus small d square divided by 8d. You should remember this relations, okay, in the core section. Okay, sometimes in the examination you will get the question, find the core or rectangular section. We'll see the one example. Here you have given the rectangular bar having the width. Okay, this B value is given 300 and depth is given 400, and we want to find out the core of that rectangular section. Then how to find out the core of the rectangular section? Means what? We want to calculate the value of the eccentricity about the section XX and eccentricity about the section YY. Remember that. First, what is the core? This distance from the centroidal axis to the rectangular, means we want to calculate the eccentricity value. Okay, this coordinate value we want to calculate. Then how to calculate this Ex? You know that the formula for the last lecture we have seen for the rectangular, Ex and Ey. What is the Ex? Ex is equal to Zx upon area. Okay, A. And what is the Ey? Ey is the eccentricity about the section Yy. You will get the Zy divided by area A. Okay. With the help of this, you can calculate the find out the core of the rectangular section. Then how to calculate the Z value for the rectangular, Zx and Zyy? Yes, anybody? What is the Zx? Yes, we know that. Again, what is the Z? Ixx by y bar. Okay, Ixx by y bar value. And what is the Zyy? Zyy is again Iyy divided by y bar value. Then you will get the Zx and Zyy. This value you should put in this equation. Okay. Again, you know the Ixx and y bar. Area of the rectangular, you know, B into D. Easily you can calculate. In this way, you will ask the question in this unit. Means you know, you should have the knowledge of the unit number 1 to 5. Okay, I will start. First, I will find out the area of the rectangular section. Area of rectangular section. What is the area of the rectangular section? A is equal to B into D. You know that. What is the B? 300 into 400. Means you will get the mm raised to 2 mm square. Okay. 1,20,000 is there. 300 into 400. Check that. Then second, we want to calculate the value of Zx. Okay, I will calculate here section modulus. Section modulus about which section? XX section. Okay, section modulus about the which section? XX section. Then you know that I have already solved yesterday this formula. Zxx is equal to Ixx divided by y bar. Directly I will write here bd square by 6. What is the Ixx? Bd cube divided by 12. What is the y bar? D by 2. This distance d by 2. Then you will get the formula Zxx is equal to bd square divided by 6. Okay. If you have put this value in this equation, what is the B? 300. What is the D? D is 400 square divided by 6. If you have calculate, then you will get the 18 to 10 raised to 6. What is the unit? Unit of Ixx or I movement of inertia is mm raised to 4. And what is the unit of y bar? Mm. Then you will get the mm cube. Remember that. Unit is very important. Similar way, we want to calculate the section modulus about the y bar. Okay, y bar. You know the formula. This b is replaced by the d. Then you will get again here db square divided by 6 is there. If you have put this d is 400 and b is 300 square divided by 6. Then you will get value. This value you will get 6 into 10 raised to 6. What is the unit? Again, mm cube is there. Mm cube is there. Then once you have got the Zxx and Zyy value, then easily you can calculate the eccentricity core of rectangular section value. Ex is equal to, we know the formula Zx divided by area. What is the Zxx? We have calculated 8 into 10 raised to 6. What is the area? 12. Okay. 1,20,000 Then if you have solved this, then you will get this value is 66.67. This is in mm. This is in mm. Okay, you will get this mm cube divided by mm square. You will get the mm. And similar way, ey is equal to zy divided by a. What is the zy? 6 into 10 raised to 6 divided by 1,20,000 is equal to, you will get the, this one is 50 mm. Once you have got this both value, then you have to draw the core of rectangular section. And how to draw this core of rectangular section? Where we will get this eccentricity? I will show you. See, first this is the given. Okay, this value is given width 300 mm and this value is given 400 mm. Depth is given 400 mm. Let's take the section XX and YY, right? Then see what is the EX value. Then 66.67. If you find out the coordinate, then you will get the, this value is, I will mark approximately, this is the value, you will get 66.67 mm from the center, then again 60.67. This, which is this value? Yes, what we have find out? 2EX, right? 2EX. And what is this one? Here is a 2EX, and this value is a 2Y. Yes, approximately you will get the, this is the over section. This one is a 50 and this one is again 50. Okay, yesterday I have shown this is divided here up to the 100 mm, then this one is a 100 mm and remaining value is a 100 mm. Okay, this is the over section. Okay, all of you getting very simple numerical is given. Only you have to find out the over section. You should remember the generalized formula. We have seen already in the unit number 3, right? You know the what is the EX. Okay, you have to start from the end. Okay, think about the end. What we want to find out? We want to find out the EX and EY value. What is the formula for that? ZX divided by A and ZY divided by A. What is the again Z? Sectional modulus. It is the ratio of moment of inertia to the Y bar. Y bar means what again? Topmost distance from the central line axis, centroid axis. Okay, this is the Z. Okay, what is the unit of Z? This is mm raised to 3 or mm cube or meter cube. Again, what is the moment of inertia? How to calculate that? For different section, we have seen how to calculate the moment of inertia. If you have given the rectangular section, this moment of inertia about the x-axis bt cube divided by 12 is there. Okay. For circular section, pi by 64 into d raised to 4. Again, we have seen the hollow rectangular section, hollow circular section. Again, we have seen the square section. Each and everything we have seen related to the sectional modulus and moment of inertia in the unit number 3. Okay. In this way, you have to find out the value. That's it. Okay. This is the new unit is included the basis of application based combined loading and stresses. Okay. You will get the any questions on the from the unit number 1 to 5. You have seen the different formulas. We have studied the different theories. Okay. On the basis of this, you will get the question in unit number 6. That's why you have to, once you have studied from unit number 1 to 6, 1 to 5, automatically you can find out the value for the unit number 6. Today we will stop here. Next lecture again we will see the different numericals. Thank you.